In this video, we want to talk about arteries and veins, and just in terms of defining arteries and veins, because from there we'll get into the various pipes. When I say pipes, I mean arteries or veins. Which artery or vein or pipe brings deoxygenated blood to the right heart, and so on and so forth. So these are the learning objectives. And the last one then looks at something called papillary muscles and chordae tendineae. So let's get into that. So by definition, an artery is a blood vessel that carries blood away from the heart, and a vein is a blood vessel that carries blood toward the heart. So remember that you got two sides of the heart. So if there is a blood vessel that is bringing blood toward the heart, then we call that a vein. If it's moving blood away from the heart, we call that an artery. So the question I have at the bottom, and you may wish to pause the video to take some time to think about it, is which one of those, arteries or veins, is more likely to contain oxygenated blood? Okay, so let's say something like you've got, where the radius is in the forearm, you've got a radial artery and you've got a radial vein. You got an ulnar artery and an ulnar vein, all the way throughout the body. A lot of times, not every time, but a lot of times wherever you see a named artery, there's a similarly named vein. And so which of those is more likely to contain oxygenated blood? And your thinking should be, well, it would seem to me that if you're carrying blood away from the heart, you're carrying it probably to some end organ somewhere to deliver oxygen. So it's more likely that arteries carry oxygenated blood. And you'd be correct. So arteries generally carry oxygenated blood. The one exception is in the pulmonary circuit. Veins then carry blood toward the heart. And again, these are generally speaking deoxygenated, with the one exception being in the pulmonary circuit. And so when we look at this picture, there's our superior vena cava, inferior vena cava, and coronary sinus all dumping into the right atrium. Okay, we've seen this before in a previous video, and then we go into the right ventricle. So there's the right atrium. So it's showing you here in blue. Then blood going into the right ventricle right over here. And then blood is getting pushed out of the right ventricle. And where is it going? You already know the answer. You know the answer is it's going to the lungs. Well, what is the named pipe that exits the right ventricle? And the name of that pipe is the pulmonary trunk. What ends up happening down the road just a little bit is you'll see that pulmonary trunk bifurcates. It splits off there, and that pulmonary trunk is this big thing, and it branches off into the pulmonary arteries. And the pulmonary arteries then carry deoxygenated blood to the lungs. So again, is it true that they are arteries? Yes, they're carrying blood away from the heart, right, going to the lungs. And in this case, this is that one exception where an artery has deoxygenated blood, because this is going, again, into the pulmonary circuit. On the other side, we see the left side. And so there is blood that ends up, and we're going to read this thing right to left, following these arrows. Blood is returning from the lungs back to the heart, and there goes into the left atrium. Now blood's in the left atrium. It goes through that mitral valve into the left ventricle. And from there, what is the name of the pipe that carries blood out of the left ventricle? And the name of that pipe is the aorta. The name of that pipe is the aorta. So where we're at here, which pipe brings deoxygenated blood to the right heart, or which pipe or pipes do so? And those would be the superior vena cava, inferior vena cava, and the coronary sinus. Then which pipes carry deoxygenated blood away from the right heart? And that would be the pulmonary trunk, which then splits off into the pulmonary arteries. Which pipes carry oxygenated blood to the left heart? I don't think I actually named those, did I? The pipes that bring oxygenated blood into the left side of the heart are the pulmonary veins. So the pulmonary veins are doing so, and you see those listed right over here. These are the pulmonary veins over here, and they will actually dump into the left atrium. So again, why is it a vein? It's a vein because it's returning blood to the heart, but this, because it's part of the pulmonary circuit, is the one that has oxygenated blood. So this is a vein with oxygenated blood. And then finally, let's see, which pipe carries oxygenated blood away from the left heart, and that would be the aorta. So we've basically covered all these learning objectives. Just to give you a different view, when you look at this, we're looking at an anterior view of the heart, and this is the superior vena cava. There's the inferior vena cava, and if we were to peel this thing open, which we can do right over here, we would see that the superior vena cava dumps into the right atrium, as does the inferior vena cava, and then this is the opening to the coronary sinus, which will also dump into the right atrium. Some of the other parts that we see there is the pulmonary trunk, and remember that pulmonary trunk splits off into the right and left pulmonary arteries, and again these are carrying deoxygenated blood into the lungs so that the lungs can dump in oxygen. If we were to crack this open, we would see that that emerges from the right ventricle, And there it is, right? So there is my tricuspid valve, blood ends up here, and then there, right there is my pulmonic valve or pulmonary valve going right into my pulmonary trunk. Okay, so this is direction. This is right atrium, right ventricle, and then blood gets pushed out over here into the pulmonary trunk. Then we see the pulmonary veins coming right back over here, and I think if we flip the heart around, this is a posterior view, there's a better view. There are the left pulmonary veins, these are the right pulmonary veins, both of which are returning oxygenated blood into the left atrium. And so again, that is, again, from the anterior view, you'd see they tuck in there. If we peel this open and look into the left atrium, there we have it. And these are the openings. See those little indentation? These are openings of the pulmonary veins, and there would be more on the other side. You just can't see them. These are openings of the pulmonary veins into the left atrium. From there, we go out the mitral or bicuspid valve into the left ventricle, and lastly, out the aortic valve, which is this guy right over here. There's the aortic valve. And what's the name of that pipe that it dumps into? It's this thing, the aorta. And there's your aorta right over there. Okay. Now, one of the things that you'll notice is that, in previous videos, I gave you this kind of quick and dirty diagram just as a general schematic to see where the right atria and ventricle lie with respect to one another. And here I put the valves at the bottom just so you could kind of get some sense for them. But you'll notice here, when you actually look at the real heart, the valves are kind of all roughly along the same plane. There is the tricuspid valve, and even though this is the right ventricle, it's not like the pulmonic valve is down here, like I had in that box. The pulmonic valve is actually up here. Same thing, here's the mitral valve. It's not like the aortic valve is down here, like I showed you in that box. The aortic valve is right over here. So they lie roughly in the same plane. If you were to kind of take a plane and go like this, these valves lie roughly in the same plane. Okay. Let's see. The last learning objective that we want to get into is the function of the papillary muscles and the chordae tendineae. So here's what I want you to see. When you look at papillary muscles and chordae tendineae, these things are coupled together. These little strands right over there are called the chordae tendineae, and you got chordae tendineae right over here as well too. Those are these little thin strands, and these guys are the papillary muscles right over here. These are all papillary muscles. So papillary muscles are attached to these things called chordae tendineae, and chordae tendineae are essentially tendons. So the way to understand this is that these chordae tendineae actually attach to the flaps on the valves. They attach to the flaps on the atrioventricular valves, and here's why. These muscles are there to prevent atrioventricular valve prolapse. One more time, these valves are there to prevent atrioventricular valve prolapse. What the heck is a prolapse then? So what I want you to do is imagine a valve right over here. Okay, so I put in this little PowerPoint image. So let's just call this right here the tricuspid valve. And so what I want you to imagine is that this valve then, of course, can open up and allow blood to flow, and then it can close. It doesn't quite pivot like that, but the flaps will open up and then it'll close. What I want you to imagine, though, is that this right ventricle is squeezing really hard. When this right ventricle squeezes, these flaps will actually end up closing. And the way that looks, let me go to the next slide, is something like this. Here, we're seeing that this now, a moment ago, I was showing you the tricuspid valve. Now we switch to the bicuspid valve, but it's the same principle. So these valves are open, and they open when blood is going from the atria into the ventricle. And now my papillary muscles are relaxed. But what ends up happening is that as this chamber fills with blood and as the ventricle begins to squeeze, some of that blood will shoot up back north. And as that blood shoots up back north, what will happen is that it will fill these cusps, almost like wind fills the sails on a sailboat. And that is what's going to force these valves to close. And so these valves now are closed. So what are these contracted papillary muscles doing then? What they're essentially doing is they're taking these valves, so that my cusps have closed, and they're taking these valves and pulling them this way, in this direction. Now, obviously, you're not pulling all the way down this way because then the flaps are just opening back up. But what you're doing is that you're pulling them this way because when the ventricle squeezes really hard, these cusps can flip over. And they flip over and they end up flipping into the atria themselves. To say it differently, that when these cusps fill up appropriately with blood, they close. But if they're super duper high pressure, these things can flop open. It's almost like if you've ever held an umbrella on a really windy day, you know how the umbrella kind of domes down, and then the wind comes along and all of a sudden your umbrella like flips the wrong way and it kind of, points a cone up towards the sky, that kind of thing. And so that's what actually can happen with these valves, because that the ventricles squeeze very, very powerfully. So to prevent that, to prevent pushing of the valves into the atria, which would essentially lead to a leakiness of the valve, we have papillary muscles contracting along with chordae tendineae to stop that movement. So again, right over here, here's your valve. What I'm doing right now is this is atrioventricular valve prolapse. This is the valve smushing too far into the atria, allowing small amounts of blood to squirt backwards. And so we don't want that to happen. That is a not desirable situation. So we have chordae tendineae and papillary muscles to prevent that. All right. So in this video, we've defined arteries and veins as carrying blood away from the heart or toward the heart. In general, arteries carry oxygenated blood except in that pulmonary circuit. And same thing, veins carry deoxygenated blood except in the pulmonary circuit. We talked about superior vena cava, inferior vena cava, coronary sinus, bringing deoxygenated blood to the right heart. We talked about the pulmonary trunk, which then bifurcates into the pulmonary arteries, carrying deoxygenated blood away from the right heart. We said that the pulmonary veins carry oxygenated blood back to the left heart, and the aorta carries oxygenated blood away from the left heart. And the function of papillary muscles and chordae tendineae is to prevent atrioventricular valve prolapse. Again, these structures are only present at the AV valves. They're not present at the semilunar valves. And that'll do it.